This is a video on how to manage a differential temperature low alert on a Siemens MRI system. So this alert came through last night. It comes with a clickable link, which you will click on. It will take you to the green board view of just this one site. If you're not familiar, you should be familiar with the green board in each of these cells before watching this video. So the differential alert is telling you what's going on with the compressor 1 button here, which we're going to press. So let's press it. It takes you to a graph of the incoming and outgoing water temperatures going in and out of a cold head compressor. So the blue line represents the incoming water temperature, the black line represents the outgoing water temperature. These should be at about 15 degree difference if everything's running normally. If the cold head compressor stops working, then they come together, just like that. So this is what it looks like when the helium compressor, when it stops working all of a sudden, but the chiller continues to work. The outgoing temperature comes together and meets the incoming temperature very quickly. So if this were chiller overheating before all of this happened, then the blue line would be going up before they came together. If this was a power related issue on the chiller and the cold head compressor at the same time, then that outgoing temperature would meet the incoming temperature. The black and the blue line would come together, but much slower because the pump isn't running anymore, so it's not transferring heat very quickly anymore. Okay, so now let me show you what you should be looking closely at when this happens. You want to evaluate, did I lose 480 power? Did I lose 110 power? So I'm going to take you into how to evaluate that. So this is where 110 power is represented. If power goes to 0 and the UPS is on battery, then this will go to 0 volts. This is our best indicator of 480 power. So this is the last time that the MSUP communicated to the RDU. It stops communicating when you're scanning. It also stops communicating when it loses 480 power. So let's dig into what these things look like in the flight recorder, we call it. So let's click this button here, and it'll take you to spreadsheet fashion information that you were looking at on the green board. This is a historical view. What we were just looking at is a real-time view. Let's look at a one-day view here, and then we can go to this actual error. Alright, there you are. Okay, so you can dig into the flight recorder and see what actually happened here. This looks like a power surge that was very quick, and everything came back online as soon as it happened. So the UPS is tracking power surges in numbers here in this column here. So when it switches to battery or it switches to like a surge protector, it tracks from 1 to 2, and you can see it went from 1 to 2. When it's on battery, right now it's online, but when it's on battery, it'll show on battery. When it's shutting down, it'll say it's shutting down. When it loses power altogether, it'll show you there. That's the amount of volts. Now this is all the magnet information coming from the MSUP. So you get blank readings when you're in the middle of scanning, or when 480 power is off. So it looks like 480 took a hit here, a power surge, and the MSUP stopped communicating for a short amount of time, and the chiller continued to work. And you can see it started talking again pretty shortly, and then it read that the compressor was off until the compressor knew that it had flow, and then it turned the compressor back on. And you can see the differentials represented here. Same thing that we saw on the graph. So, that's it.